Given three quadratic equations. First one, I'm going to write out all the logic of this, and you should do that on several problems. Ax squared plus bx plus c equals 0. If a equals 1, b equals 7, and c equals 6. So the solutions are these. And I did give you this expression. Okay. I didn't give you this form or say that that's what x equals, but I think you've done the appropriate way. You immediately recognize that as the expression you need to evaluate by the quadratic formula. Okay. So, well, now we just have negative 7 plus or minus the square root of 7 squared minus 4 times 1 times 6. All that divided by 2 times 1. Everybody's good with the substitutions. It's good. Everybody gets arithmetic right. So this is going to be square root of 25. 49 minus 24. So I'm not going to write out that step of arithmetic. So you get negative 7 plus or minus 5 divided by 2. Okay. Equals, I'm going to write it like this, negative 7 plus 5 divided by 2, or 7 minus 5 divided by 2. I'm going to put that word or in there. You want to repeat that word so you really get used to what it means, because it can get confusing between and or when you're doing mathematics. Okay. So that equals what? Well, negative 7 plus 5 is negative 2 over 2, which equals negative 1. And negative 7 minus 5 over 2 is negative 12 over 2. 6. Now, I'll comment that this factors as x minus 1 times x minus 6. So x minus 1 equals 0. We give you a solution. And x plus 1 equals 0. We give you a solution. And x plus 6 equals 0. We give you a solution. Okay. We saw that when we talked about factoring. So anyhow, solution set. Except that would be the icing on the cake. That's a specific thing that you would want to be looking for. So do recommend practice writing this out. Okay. Now here, form is not ax squared plus bx plus c. But you have an x squared, you have an x term, and you have some number. So what we do is subtract 2 from both sides. Get x squared plus 4x plus 4 equals 0. Now we're in the form ax squared plus bx plus c equals 0. If you look at your equation and you've got x squareds, you got x terms, and you got just plain old numbers, then you can put everything on one side, and you'll have 0 on the other. You have to have 0 over here, it doesn't work. Okay? So, well, solutions then are x equals -4 plus or minus the square root of 4 squared minus 4 times 1 times 4 over 2 times 1. And that's going to be -4 plus or minus the square root of 0, because 4 times 1 times 4 is 16, and 4 squared is 16. And that's 16 minus 16. It's going to give you 0. That equals -4 over 2, which is -2. Now, I'm going to comment. We're storing this away if you got pre-calculus coming up anytime soon. Even though you're probably going to forget it, it helps to see it. It's a mystery why. A repeated solution, as you get the same thing for the plus as you get for the minus. Okay? Your solutions, you have a plus or a minus. Plus gives you the same thing as the minus. But there are two solutions. And that has an important implication, more than one important implication, for the graph of this function. You want to graph this thing? It helps to know that you have a repeated solution at x equals -2. Okay? I'll even tell you what it tells us. It tells us that the graph comes down and touches the x-axis at x equals -2. Okay? So there's a reason for learning this. Now we're not gonna, y'all have done really well with graphs, so I think you can understand the picture. Okay. And we can even complete the scale on this. If x equals 0, we're going to get 4, right? Well, x equals 0 on the y-axis. So right here is the line, y equals 4. Now we've got a pretty good picture of that graph. Okay, that's something you can draw a decent parabola. And we're not gonna get into that, but we do in pre-calculus. Okay, over here, this little box. Now these are written probably too small for you to see if you're sitting any distance away. But this first dotted line is at line x equals -6. The other one is x equals -1. Half point and this point. Then it goes through y equals 6. The y-axis at 6. I didn't get it right. The low point should be on the line halfway between these two, and the y-intercept should be y equals 6. Now, that's -6. Doesn't look like that's 6, but we can do it. So you take that for what it's worth. All I'm saying is that when you solve quadratic function, if f of x equals x squared plus 7x plus 6, then its graph is going to have these characteristics. Okay? And the low point is halfway between these points. There's symmetry and all that sort of stuff. So there's a lot to learn about it. But if you have the quadratic formula down and understand how factoring can give you the 2 zeros, you're off to a really good start. And that's what you can carry out of this class. At least carry out enough understanding of that when you see it again, you say, oh yeah, I've seen this. It's good to do this. Okay. Now this one, which involves denominators, right? So we're from tank. Denominator. Okay, well. You get used to writing that down. You know, if dang is too strong, you can use a milder word. Doggone. Food. Okay. Okay, common denominator is 3 times x. Instead of writing 3x, I'll emphasize it's 3 times x. I'm abbreviating this more than I'd like to. I should say multiply both sides by the common denominator, but we know that when we multiply one side of an equation by a number or a quantity, we have to multiply the other side or we destroy the equality. Okay, so we got then 3x multiplied by x over 3 plus 2 over x is 3x times 5. Well, the right-hand side is easy. It gives us 15x. On the left side, let's use a distributive law. We're going to multiply this. We're going to use the 1 as our denominator to remind us that we're multiplying numerators and multiplying denominators. I overly optimistic when I wrote out that 15x. Thought I was going to be able to get the thing weren't that high, but I looked to my left and would realize that. Okay, so here we have it. Now we can multiply this out. We get 3x squared divided by 3. But the point is, if we multiply out the numerators and denominators, 3 is a common factor. Okay, so this 3 will divide this 3, just give us a 1. That just leaves us with a bunch of 1s in that square. So we're going to have a little square. This x will divide this x, leaving us 3 times 2. This 2 will also divide this 2, right? That just leaves us 3 equals 15x. Okay? Run out of room here, but we subtract 15x to get the form ax squared plus bx plus c equals 0. And of course, I mean subtract it from both sides, because if you subtract something from one side, you got to subtract it from the other, or you destroy the equation. Okay, so we have x squared minus 15x plus 3 equals 0. And that gives us x equals 15 plus or minus the square root of 15 squared minus 4 times 1 times 3, all divided by 2 times. So I'm going to use this little bit of space here, real short. That's 15. That's 12. That's 225. So that's 213. 15 plus or minus the square root of 213 over 2. Now 3 divides 213 71 times. 71 is a prime number. So we're not going to be able to divide a square out of that number. You don't have to worry about overly much right now, just there's a bare bones introduction. But you do check and see if there's some square that divides into this. Like if this was 7 times 31. So why would I say 7? Anyhow, if it was 7 times 32, that would be 7 times 2 times 16, and you can take the square root of the 16. But it isn't, and you can't do that. Okay. So I'm going to say about that. There are your 2 solutions. Now, if you want a decimal approximation, you can take your calculator and get it. Okay. Square root of 213, I think it's about 14.6, maybe 7. Okay. So you get a number here and here, and you could then use those numbers to determine where the graph of this function would go through the x-axis, which goes a long way toward graphing the thing. But that's something that you'll be doing in pre-calculus. Okay. Okay, so all that makes sense, at least most of it. I mean, some of my side comments, a little bit of enrichment there, a little bit of a pointer to where you're heading. Okay. So make sure you know how to use a quadratic formula. Make sure you know if you have something like this where you got your x's and x squareds and your numbers scattered over 2 sides, you got to pull them all onto one side, so they have an equation that's equal to 0. If you've got denominators, you multiply by the common denominator. And in this case, you get numbers scattered over both sides, so you subtract 15x from both sides, you get this equation, which comes out very easily, even though the numbers got a lot of decimal places in it. Okay? Infinite number decimal place, you got to round it off.